Okay, good morning. Welcome to
FamilyMath186a.
FamilyMath186a. So today we've got a number theory problem I saw on Twitter from Dave Radcliffe. Sort of our last one, I don't know if you remember it from 2 weeks ago, was also a number theory problem. But I was traveling last week, so we didn't do a family math. So it says, here's this question. 10 is the product of all of its proper divisors. So 10 equals 5 times 2 times 1. What does proper divisors mean?
Proper divisors are the divisors and not including itself, they were all the divisors of 10, not including 10.
Okay, so all the divisors of 10, not including 10. Alright?
Yeah.
Describe all numbers with this property.
Well,
It's a pretty interesting question.
yeah.
I think all numbers with this property, like if you write it our divisor chart,
Okay.
so let's call our number x, and then we have to have two sets of divisors only, otherwise it's going to be bigger than the number.
Oh, okay. Very interesting observation. Let's do an example. What's a number? Let's find a number that has more than two sets of divisors.
Well, 16.
Okay. You want to write it? You want to write the divisors of 16? Go ahead.
16 is 1, 16, 2, 8, and 3, 4, and 4.
Okay. All right. Good. Now I don't know if we can see that on the camera, so I'll just write it just a tiny bit bigger. Okay. So 16 is 1 and 16.
2 and 8.
2 and 8, and then 4. But we already wrote 4, so we're not going to write it again. So what happens here? Is this going to work for 16?
Well, we don't use the 16.
Right. We don't use the 16.
But this 2 and the 8, they already multiplied to be 16.
And then
Okay.
you have the extra 4.
Then you have an extra thing. What about the 1? Does that cause problems?
No,
How
the
come?
4, because anything times 1 is just 1.
All right.
Anything times 1 is itself.
Ooh.
Yeah.
Yeah. Anything times 1 is itself.
Yeah.
Anything
Yeah.
times 0 is 1. Or anything times 0 is 0.
Which one?
0.
All right. Anything plus 0 is itself. Right.
Yeah.
Okay. All right, so here's an example. If you have more than 2 rows, and even just one more number, it messes up when you do the divisor chart. So that's an interesting observation. Do you want to try to find a different number other than 10 that has 2 rows?
Well, 15 works.
Okay, how do you know 15 works?
Well,
It's 3 times 5.
1, 15, 3, and 5.
It seems like for the factors, for when you write it out in this form, it seems like you only use powers to the 1.
Okay.
So this works. You don't use the 15. 3 times 5 is 15, and 3 times 1.
Okay. Pretty interesting. What do you think? Do you have any ideas here?
Well, I think all of the numbers that have this property are going to be all of the numbers that have, I think exactly 2 rows.
Exactly 2 rows.
Because
right?
if you have 1 row, which would be a prime number, you exclude the 15, you just have 1.
Oh, give me an example of that so we can show.
Well, 7.
All right, so 7. There are numbers that have just 1 row, 1 and 7. And so we exclude the 7.
And then
Just 1.
Product's 1. So if you just have 1 row in your divisor chart, the product's just going to be 1 when you exclude the number itself. If you have more than 1 row,
Then
it seems like it's going to be bigger. And if you have exactly 2 rows, the second row
works.
gives you the product, and then you just multiply by 1. Very good investigating, guys. So this problem, describe all the numbers that have this property, boils down to what are we trying to find?
We're trying to find all of the numbers with exactly 2 rows of divisors.
Very good. Very good. Do you understand that?
yeah, that would
All right.
mean
Whoa, I'm going to go to the next movie just because it's a new So I didn't
Alright.
touch, okay?